Hello, good afternoon, everybody, and welcome to our workshop, Going Beyond Innovative Integration of Sustainable and Energy Efficient Solutions in Building Design. My name is Josh Korke, and I'm a senior researcher here at Instituto Pedro Nunes in Portugal, and the coordinator of EU research project Powerskin Plus. I'm delighted to see that we have such a wide group of participants joining us live today through YouTube, and to learn a little bit more about some of the work and the cutting edges advances being made in Europe towards a more sustainable and, I would say, energy efficient construction practices, as buildings continuing to account for a substantial share of energy usage and greenhouse gas emissions. I would say that to attain this ambition European Union carbon neutrality goals by 2050, we can only rely upon innovative building solutions that can enhance both energy efficiency and sustainability. Our workshop aims to be just a small contribution to drive and to accelerate this transition towards a more environmental cautious construction industry in Europe. And for that, we have a wonderful list of speakers today, coming not only from academia and research institutes and centers, but also from companies and associations in the building sector. I hope that you can expect some insightful presentations on groundbreaking thematics and technologies. This way, our agenda lineup for today delves into a very broad spectrum of cutting-edge topics, from prefabricated multifunctional systems and envelope solutions addressing the building facade retrofit actions and the quest also for zero energy and zero emissions buildings, up to advanced glass and super insulation materials, simulation tools for energy efficiency, the latest innovations dealing with the integration of renewable energy harvesting and storage in building facades, and how we can rely on biogenic materials for carbon sequestration. So we have with us today, hopefully, Riccardo Pinotti from the Iraq Research Center in Italy. We have Stefan Schaffer from the German Flash Glass Association. We have Roel Lunen from the Eindhoven University of Technology in the Netherlands. We would like to have a speaker, and we had it listed, to talk about novel advances on building integrated photovoltaics in facade systems. But unfortunately, I was told that he cannot attend. I am very sorry for this, because it would be great to know a little bit more about this important contribution for effectively harvesting renewable energy in our facades. But it has to be for another occasion. I believe that we have Robert Anjic from the company Turvac in Slovenia. We've got Callum Hill from the Norwegian Institute of Bioeconomy Research. We've got Filip Gabrielzik from the company Vatmechnik in Poland. And last but not least, my colleague Maria Fonti from the National Technical University of Athens in Greece. So a big agenda with a lot of speakers. I believe that the presentations that you will hear about are intended not only to showcase the latest advancements, but also to highlight, I would say, different innovations that are already available, or at least to soon be available in the market for building facade solutions. And I would put the focus particular on curtain wall systems and how these innovations can address the challenges posed by climate change and pave our way for a more sustainable built environment for future generations. Just a couple of more informations. After the end of all presentation, we will have a 15-minute Q&A session to encourage the discussion, to exchange some ideas and deepen our understanding about the topics presented. Nevertheless, if we find it more suitable to address any question right after the end of each presentation, I will personally try to manage it. So I invite you to participate using the YouTube chat, where you can place your questions and remarks and engage with the list of our speakers. We will try to review all these questions and hopefully placing it for debate. But let me assure you that if we don't have time to answer all the questions, the speakers will be available after the workshop in the upcoming days to answer any remaining question left by you using email. So without further ado, I would like to start by making a short presentation about Powerskin Plus project that hosts this workshop today. So let me just share my presentation. Probably, I hope that you are seeing it. Many thanks again for your participation. Let me just give you some very brief presentation about the Powerskin Plus project, entitled Highly Advanced Modular Integration of Insulation, Energizing and Storage Systems for Non-Residential Buildings. It was a research project funded on the 2019 Energy Efficiency Buildings Call, the integration of energy smart materials in non-residential buildings. And we come along from 2019 up until this month. Actually, we are in the verge of finalizing the project. Just to give you an idea about more about the partners than the structure, because the structure is very common to many different types of research projects in this field. But to let me tell you that we had 14 partners from 8 countries. We had 6 universities with us, 3 research institutes, and a great number of SMEs. We had 5 SMEs within our consortium. The project goals were very, very straightforward. The aim was to generate innovative hybrid-enabled systems enhanced with different multifunctional add-on features, and to demonstrate all these systems in a true holistic facade solution in operational environment. We were aiming to new buildings, but especially we would like to provide the retrofit market with this highly adaptive multi-case energy efficiency and measurement solutions. So we tried to gather a number of key enabling technologies for smart curtain wall facade solutions, dealing with nanos and super insulative and energy efficient elements, multifunctional nano coatings, solar energy harvesting components based on flexible solar cells. We dealt with active and passive thermal storage materials and elements, and also with electric energy storage features. And we tried this, trying always to focus on providing the future market with both standard, a little bit more budget, a little bit less costly solutions, and also a bunch of different combinations possible, which will be obviously a little bit more premium in terms of cost, but we tried to get different solutions for different geographical conditions, different building types, national regulations, and obviously budgets, trying to find a true energy measurement turnkey package following superior energy efficiency and sustainable eco-design standards. Just to give you a glance of what we've tried to do. So basically, we divided the project in transparent and opaque modules, and we always try to find a standard package. In the case of the transparent model, that could start with a modular framing system that can be a metal or a composite one, a stick or unitized system installation, and then combine it with low E and reflective coated triple glazed insulation glass units, standard IGUs, and then trying to fill it with different layers of add-ons. And for the transport module, we had microfluidic devices for active thermal storage in the version using these capillary glass sheets with heat storage materials. We enhanced in the premium designs these transparent modules with facade building integrated photovoltaics based on semi-transparent perovskite PVs. And we've combined these PVs and this harvesting energy solution with a building electric storage and management system coming from autonomous electric storage system using recycled e-car lithium-ion batteries connected to the PVs. That can be any PV, doesn't have to be the perovskite one, and also with the grid. Finally, these transparent model add-ons can be composed with functional nano coatings for self-cleaning, anti-reflective, photocatalytic properties, and wavelength control for the PVs. The opaque model, the standard package, again a little bit less costly, starts again with this modular framing system, combined with skin frames made out of glass, composite, or metal solutions, having inside a super insulation module made out of vacuum insulation panels, VIPs, and also with recycled EPS frames. The upgrade package combining this initial solution obviously can be enhanced with functional nano coatings for UV weatherability, for instance, and fire resistance capabilities. And we also provide an add-on with latent heat storage systems based on phase change materials. Again, like in the transparent model, we combine this with facade building integrated photovoltaics, perovskite ones, opaque perovskite ones, and the combination with the same electric storage management system that I've described previously. So the transparent models, triple glazing IGUs with using solar control low E glass coatings, a very standard one. But then in the upgrade package, it can be combined with different functional coatings, with different solar thermal harvesting solutions, the glass capillary system that we've developed, or with the semi-transparent perovskite solar PVs that I've talked before. This is the way that we envisage how these transparent models could work in different solutions. Regarding the opaque models, we've developed mostly 3 different types of possibilities. A very lightweight standard one, a market entrance one, and specifically designed for cases in the facades where you can have some weight restrictions and special wall facade sprandals. But then we can have it a little bit more standard, using different types of VIP systems, different types of skins that are not that much lightweight as the initial one, that can be composed of opacified glasses or aluminum composites. And the premium opaque models are basically the entrance one plus the different add-ons. We are talking about this thermal storage solution, heat storage solution from PCMs with an activating heating foil, and flexible opaque perovskite building integrated cells in different dimensions, in different colors possibles for all sorts of application capabilities. Again, some figures, rationales about our opaque models and how the market entrance opaque solution behaves, and then the different upgrade opaque solutions, which we would like in the market to have this tailor-made for different necessities from each building or each location or each building regulation code. The opaque model's thermal insulation submodel was based and is based on vacuum insulated panels. Probably you already know, you all know about VIPs, and we will have a session later on talking about VIPs. Just to tell you that the superior thermal performance of VIPs at reduced thicknesses make these types of elements outstanding candidates for the building industry, especially for curtain wall systems, prefabricated curtain wall systems. And we've developed very innovative core systems for these VIPs. We've submitted some patents. We are on the verge of submitting others. So this was part of our research during the project. Regarding the latent heat thermal energy storage, as I told you, it was based on PCMs. In the pictures at your right, you can see actually our PCM pouches and the electric heating foil system that we use to trigger the PCM's melting stage. And let me tell you that these heating foils are triggered and powered by the PV system. So there's no need to use electricity coming from the grid, and we use these different PCMs in the Powerskin OPAC models as a passive thermal energy storage solution, taking advantage of the solar thermal energy, but also to prevent the PV overheating. And in this way, as you all know, facades, especially here in Portugal, can attain quite high temperatures during the summer, and this is very dramatic for the PV's service life expectancy. So and workability. So we used also this PCM system to trying to overcome this overheating. Regarding the add-ons for the transparent model, we have this a patent glass-to-glass capillary fluidic device for large area integrations with adaptive facades and smart windows. Basically, these are flat laminated fabricated glasses through a microstructured glass sheet and a thin cover glass using a polymeric interlayer. And within these capillary channels are filled with the liquid, providing optical transparency. You can see at your right some examples, installed examples. Actually, you can see that it's transparent. You can see through it, and trying to enabling efficient solar thermal heat harvesting, as well as heat exchange at the outdoor temperatures upwards of 8 degrees. Actually, you also can see a diagram on how these types of large area fluidic windows can work within a system, a facade system, also to connect it with a heat pump and to diverse the heat generated in the facade towards other parts of the buildings, and to use this heat wisely. Regarding the building integrated photovoltaics, we used, as I told you before, flexible perovskite cells with power conversion efficiency of 9.5 and 11.5 for the semi-transparent and for the opaque perovskites respectively. Let me tell you that all the optimization glass lamination process was attained using the opaque modules, using opacified glass skin panels. You can see on your right some pictures of the models, the large size models that we've used and installed in some of our demos. Obviously, perovskite technology combines a lot of advantages when compared with conventional PV technologies. It's still a little bit below in TRL development, but it's increasing, and we believe that we've made some advances in our project towards bringing this new type of technology more into practice, and in the future will become a reality. Regarding the multifunctional coatings, we've designed, developed, tested different types of coatings for the semi-transparent and opaque models, regarding self-cleaning, self-healing, infrared reflectance, transmission enhancing, flame retardancy, using titanium oxide nanopounders, silicon oxide nanopounders, and indium tin oxide ones. For instance, we've developed coatings with a very positive impact on the efficiency of the PV solar models, with great performance increase in terms of voltage. We provided self-cleaning activity with 61% improvement. Self-healing effects also were very good. So these coatings represented quite good perspectives and similar outcomes to commercial solutions. Finally, we've developed this electric battery system based, as I told you, on recycled batteries from e-cars. The building management system that we've developed is a very versatile one, a modular one, capable of harvesting and distributing the energy along with the battery unit. It's very easy to adjust and to adapt to different building scales. It has a reconfigurable power infrastructure. It can be individual, group, or central to provide scalable power and capacity. Is compatible with the electric grid, so we can also store low-priced energy coming from the grid in certain times of the day. It includes bidirectional DC-DC battery connections for charging and discharging, designed with universal converters for, as I told you, different types of PV technologies. It doesn't have to be only for perovskite ones. It can be operated remote and in island operations, and it's equipped with a system for measure, archiving, and visualization and control. It can be controlled outside from the building. At your right, you can see a 5.5 kilowatt hour unit installation here in the IPN building, in the building next to where I am. Some pictures about the pilot production that we've made in different locations during our project. You can see over there some examples of transparent modules, some opaque modules with VIPs inside being closed. You can see the installation of the electric management system. And you can see also in the lower pictures some of a picture of our large glass fluidic device glass being installed. So a lot of work was done at industrial scale, or at least at pilot semi-industrial scale, to fulfill what we aimed for the project. We also had a lot of mock-ups and testing installations. I just put there 3 of them. In Polytechnic of Torino, we had 4 square meter mock-up with a lot of different technologies developed, standard, opaque, and transparent modules, premium ones with microfluidic glass storage systems, premium opaque models with building integrated photovoltaics. We had University of Vienna in Germany with different mock-ups, also a little bit more related with the transparent models and the microfluidic glass system. And in Brunel University, London, in the UK, we had this mock-up test cells with standard opaque modules being assessed during a 1-year period. Regarding the demo sites, we've tried that these systems were demonstrated in an operational environment in 3 different non-residential buildings in 3 different European countries, in Portugal, in Germany, and in the Czech Republic. We assessed a lot of different issues regarding these installations, regarding inner thermal and visual comfort, clean electricity production, energy savings. We've demonstrated that we had demonstration activities with installation and operation guidelines. We have been developing some BIM library, and also all this assessment was made also back up with LCA, LCCA, and social assessments towards economic and environmental sustainability principles. I'm just going to show you some examples of 2 of our demo sites. One in the Czech Republic is still being dismantling. It's part of our activity, so I will not get too much into detail, but just to say that here in Portugal, we had a 61 square meter facade. We had very big size modules, 16 opaque modules with different technologies, and 12 transparent ones, also with all the technologies that we've developed, again in very large panels, you can see in the pictures. And we also have installed BMS system, electric storage system, where you can see it in the powerhouse in the pictures at your right. In Flashglass Sützfeld, Flashglass premises in Germany, we had a smaller facade, almost 30 square meters facade, with 9 opaque models and 10 transparent ones, and also a BMS system. And we use these facades to monitoring the capabilities of the different solutions that we've developed. To finalize, let me just say that the impact and market potential of solutions like the Powerskin one, it's big. The European Union energy renovation market is very, very big. You've got some updated figures on your left over there. And also the latest Renovate Europe report states that 18 jobs might be or can be created for every 1 million euros invested in the energy renovation market. So this is something that we should look very closely and harbor this new innovations in order to speed up the transition, but also to renovate the economy in our continent. And considering that we might have a very, very small share of the market, Powerskin can still, and the Powerskin technologies can still be involved in a very big market rationale. So in the first years of the novelties that can be commercially deployed. So this is very important that we can bring right after the project and road to market. We are working on it. We already know more or less how can we exploit and who's going to be exploiting what within our project. We have key partners in title for making this deployment for the market. So we are very, very hopeful that we might generate some sort of impact with the innovations and with the support that the European Commission gave us. So that's it from my side. Many thanks for your attention. And now I would probably pass to the more interesting part of the session, because this is not a Powerskin Plus session. It's a much broader one. So now I would probably call Riccardo Pinotti from EUREC Research Center, who's going. Good afternoon, Ricardo. Ricardo is going to talk a little bit about prefabricated multifunctional facades for building retrofit. So the stage is yours, Ricardo. Many thanks for attending, and go ahead.
Yeah, thank you very much. My name is Riccardo Pinotti. I'm a senior researcher at EUREC Research, which is an institute based in the northern part of Italy, in Bolzano. And my presentation will be focused on prefabricated multifunctional facades for building retrofit, specifically thinking about timber applications. So at EUREC, we studied and we are studying, developing a lot of projects on this topic. And so I will provide you an introduction, basically, to this kind of intervention on existing buildings, and then some study case we developed in different European projects and national projects. So basically, these are the numbers we are all aware of. Basically, we know about the 40% of consumptions due to the building sector, their huge amount of emissions, and the strong need of a solution which can foster a deep retrofitting together with a fast retrofitting of the building stock. Basically, this retrofitting wave is not as we would have expected, and so we need some technological solution to speed it up. So what we propose and what we are studying is this intervention on existing building based, as I said before, on using prefabrication coupled with timber manufacturing in order to build these modules which go attached to the existing building and basically create a new scheme for the building, so a new envelope and a new scheme. The idea is not just, of course, to provide a new insulation in terms of thermal performances, but also to provide the so-called deep retrofit. So not just thermal, but also from the comfort point of view, and maybe from the aesthetic point of view. The aim here, of course, is to maximize the works performed off-site, so in factories, and to minimize the work done on-site, on the building site, also to reduce the occupants' disturbance, of course. So these modules, you can see an example here on the right in the picture, maybe bigger or maybe smaller. So in this case, you see a big one, but then we will talk also about smaller kind of modules. They should be easy to be applied, to be installed, and of course, an added value to the prefabrication is that we can reach a higher quality of the technology itself. As I said, it's not just about the insulation that is added, but with this kind of intervention, we are also able to integrate some multifunctionality within the new envelope. So we'll see some examples later, but basically what I'm talking about are windows, new shading systems, new ventilation machines to improve also the indoor comfort. And then whichever kind of cladding, maybe green facade or also maybe some technology capable to produce some renewables. So as I said, the aim here is to maximize the work done off-site. So the more we can reach in the factory, the better it is, basically. So the less we do basically on the building site. Here you see just some picture of a timber frame envelope. So starting from this, then of course the timber frame is filled with insulation, and then the cladding, and then there is already the space for fabricating the windows and adding other kind of claddings. So a really added value that is possible thanks to this kind of process is that if we are able to reach a good level of digitalization of the process together with the prefabrication of the process, we can really go into the so-called industrialization. So basically, this is the real aim, and the industrialization of these kind of envelopes will really help us speeding up the renovation process, hopefully. Here you see an example of a prototype we did for one of the projects we see later. It's called ForRenew. It's already concluded. It was a European project, EURA coordinated. This was a prototype of a timber frame module integrating the new windows, the new shadings, and a solar thermal panel, together with a ventilation machine beside the window on the right side. So these were the features that we tested during the prototyping activities. So a very important point, I would say very critical for this kind of intervention, is the anchoring to the existing facade. And of course, this depends on which facade we have or which kind of building we have. So it may be a concrete building, it may be a timber frame building again. So depending on this, the anchoring system has to be defined. There are different options. Here I just bring some of the options that we tried during this project. So in this case, for instance, the existing building was not enough good, let's say, to bear the whole structure of the new modules which are installed, and that's why it was decided to create a new foundation to load the vertical to bear the vertical loads, and then horizontal loads were bared by these timber beams attached to the structural part of the building. So on the concrete on the ceiling, for instance, we were able to attach some timber beam to which we then attach the new modules. And maybe from this picture, it's already possible to see a typical stratigraphy where you have, of course, the existing structure, Then you have a small layer of insulation, which is the so-called adaptation layer, with the adaptation, sorry, which is basically a soft, in this case, it was a soft density, low density wood fiber insulation. And this is needed in case the existing building has unevenness. And so this, by pushing this soft insulation, the unevenness are gone, let's say. And then there is the whole structure of the module, which is maybe, I don't know, OSB, then the timber frame filled with insulation, and then the ventilated facade or whatever kind of cladding. Here you see some kind of installation that provides the multifunctionality. So as I said, an horizontal section where we can see top left the installation of the ventilation machine, and then the solar thermal panel on the right. Here again, other kind of integrations dealing with I guess it was a ventilation machine again, and also its ducts. So all the ducts going through the prefabricated facade. So we start now with the first case study coming from this For Renew project. Here we had 4 buildings to be renovated. And in each one we tried some of the features of this kind of intervention. So basically here you see on the right, on the left, the pre-retrofit condition. Of course, they were all quite poor buildings in terms of thermal performances and as well as indoor environmental quality. And so all the interventions were done in this sense. So on the right, you see the final outcome of the renovation. In this case, in Norway, we added the new facade as well as the new roof, prefabricated both. Some PV panels integrated and new windows integrated in the modules, together with a ventilation machine which was installed behind the building, exploiting a cavity which was already present there. So this is the Spanish demo, concrete building, quite again, a lot of problems inside related to mold growth. And on the right, you see the final results. So there were 6 modules made of timber, and the floor, the base floor instead was renovated with a normal traditional attics. But the 6 modules above were installed in 2 days. Then, of course, more works were needed in order to finish and to conclude the works from inside in relation to the windows. But yeah, that was a good result, let's say. And again, also here we had some photovoltaic panels installed together with new shading and windows. Yeah, some picture of the process. Of course, it's really crucial the first phase of detection of the building, let's say, to create to design the modules very very carefully, let's say, that because then once the modules are done and once they are on the building site, of course, the tolerance is really small, let's say, and only due basically to the anchoring system. So again, some pictures from the prefabrication site. So the factory modules were ready, let's say, and then ready to be transported on the building site. So this is the installation phase, and you can notice that the scaffolding was not even necessary in this case. Basically, the anchoring, these L-shaped steel anchoring, were already in place. And the modules, the 6 modules, were hanged. So 2 workers were and 1 operating the crane were hanging the modules. Then, of course, as I said, some works were needed then from the inside to fix all the part around the windows. So on the website, you can see a lot of videos and time lapses of all the interventions. Another project we developed is this Legno Attivo. This is a regional project with European funds. In this case, instead of studying big modules like those you saw before, we opted for smaller modules, trying to create a sort of a configuration possible between different technologies to be installed. So yeah, in this project we didn't perform any activity, let's say, on real buildings, but it was just a theoretical exercise, let's say, together with a prototyping activity as well. We developed at URAC. So basically, we created these prototypes, a real scale prototype, including 3 modules, sub-modules, let's say. One, a passive one, integrating a duct needed for the ventilation machine, which was in the other modules, together with a window, and then a PV module. Of course, also here we studied a lot about the anchoring system, which had to be as much as plug and play as possible, and also we wanted it to be to allow the anchoring and disanchoring of the single modules independently from the others around. So also for this, we developed some prototypes and we tested them at our facilities. So here you see the picture of the let's say prestation, the prototype on which we studied performances. And yeah, so this is that one. And here you see the pictures of the small passive modules where we studied basically the functionality of the anchoring system. And so we tried different configurations of installation and uninstallation, let's say, of modules. One another really important topic that we included in this project was also the integrated seismo energy retrofit, so related to earthquakes solutions to prevent earthquakes events. And so we together with a colleague coming from the University of Rome, we studied both this kind of exoskeleton, which was embedded in the whole building, and inside this skeleton it was foreseen to have the modules for the energy retrofit. So another project that I personally worked in while doing the PhD at the University of Innsbruck. This was another timber-based envelope for retrofit. In this case, it was hosting a micro heat pump and some ducts. So here you see the stratigraphy and of course new windows. So it was tested in a passive cell. So from the hydrothermal point of view, let's say. Some analysis we did in terms of thermal bridges and trying to understand whether the presence of critical components such as the compressor and the evaporator of the heat pump could have created issues within the facade. So last case study is this one. So another European H2020 project we are coordinating at URAC. It's called Infinite and it's still ongoing. It's again related to prefabricated wooden-based facade as well as roof. And yeah, there are different technologies which are involved here in the studies. So starting from the cladding, we are studying green cladding, so green facade, and the irrigation system integrated in these new modules. Then these BIPV modules. So you see a small picture here. Basically, these are all photovoltaic panels, different colors and different, of course, efficiencies. But from the aesthetical point of view, could be an added value and could foster the use of renewables in the facade. And together with this solar thermal integrated into the facade, these are maybe we will see later in the next slide. a picture with which we see this collector for solar thermal. From the integration point of view, instead, Infinite is studying the integration of a ventilation machine. But in this case, instead of the one we saw before, this ventilation machine is ought to serve the whole floor. So it's a quite big ventilation machine with a lot of ducts to be integrated. And so this was quite challenging, let's say. And yeah, finally, some smart glazing within the windows. Okay, so here you see the technologies related to the cladding I mentioned before, so photovoltaic panels and the solar thermal collector on the facade together with the green facade. So this is just a sketch of the integration of the ventilation machine within these prefabricated modules and its ducts. On the one hand, we studied the ventilation integrated below the window, and also in this other configuration, which is on the balcony side, let's say. And these are the prototypes we developed. So the two facades are similar. On the one hand, on the left, there was no integrated solution. It was just a passive facade as a reference. On the right one, we studied the integration of the ventilation machine below the window and beside the balcony, let's say. So behind these two facades, there are two rooms which are divided in which we can study and create the condition of temperature and relative humidity that we want. So quickly to the conclusions, probably I was just to highlight the fact that due to the inefficiency of the building stock, as I said before, a real renovation wave is needed. So spot intervention are not enough, and we really need to find a massive alternative to renovating the whole building stock. And in our opinion, the industrialization of the process and the use of these prefabricated panels can be the solution. Of course, we still need to discuss the level of multifunctionality we want to have in these modules, but of course, prefabricating them could really speed up the whole process. This speeding up, of course, could be helped by the digitalization, supporting the whole construction process, not only the construction process, but also design process, as well as installation and delivering to the site. Yeah, of course, from the performance point of view, I would say it's clear that this kind of intervention has a huge potential from performance point of view in terms of thermal energy and in terms of thermal performances, as well as allowing an increase and a better indoor air quality together with indoor environmental quality for the users. And yeah, from the previous projects we had, we are still testing a lot, but in my opinion, we had just positive feedbacks and positive outcomes from previous projects. So that's why we are keep on studying this kind of topic, and we keep on testing. So yeah, that's all by my side. I hope I was
Okay, Ricardo. Wonderful presentation. Many thanks for your contribution. I had a couple of questions to ask you, but in the meantime, I was told that we have one speaker in a rush to get some sort of train or something. I don't know. This speaker is Philippe, and I would put it right on live now. And later, if you are still available, Ricardo, we can talk a little bit. I don't know about your schedule, but I would say that let's go for Felipe right now. Hi, Felipe.
Hello.
So Felipe is going to tell us a little bit about post-PV cells for building energy storage applications, and it's very, very good to hear it from you because, as you know, we've been working also with this type of technology. So go ahead, Philip.
Okay, hello, good afternoon, everybody. I will just share the screen so we can all look at the presentation. Yeah, maybe just a few words about Vamtechnik. Vamtechnik is a company, battery assembler. We actually have, I would say, more than 200 active projects, about 600 projects already made in lithium-ion technology, 30 years experience in battery technology. So I believe that we have a knowledge how the batteries behave and what can be done. We actually do the batteries in all known technologies on the market. So lithium-ion, lithium primary, lead acid, and also some nickel. Obviously, for the project and for the home appliance, I would say that current idea is to make it in lithium-ion technology. But I believe that we also have to understand some challenges when we are talking about this technology. Let's maybe pass that one. When it comes to lithium-ion technologies, right now on the market, we have the three main ones. The standard one, the most popular one is technology in 3.6, 3.7 volts. Depending on the chemistry, usually it's NMC, NCA, LCO. It's just the difference actually of the cathode material. Here in this technology, we will have the biggest energy density, and we can basically say that this technology is the most active one right now in the EV. Nevertheless, you can also find LFP and LTO cells, battery packs, which are also running in EVs. And I would say for the home storage, we would focus on the LFP technology, which is it has slightly lower voltage and a bit lower energy density. LTO, maybe not all of you know, it's technology used, for example, in the buses, because it's you can basically charge it in very short time. Like I would say 8 minutes, for example, you can recharge the bus. And when we will talk about the features, I would say that all of lithium-ion technologies are limited because of the necessity of the R&D and because we need to build, implement some kind of management system that will ensure the safety of the application, which is done. It's quite important. I will show it to you in a minute. What is the behavior actually of those cells, to understand that this energy, which is inside of the cells, inside of the batteries, is pretty huge, to be honest. And we need to ensure that we'll have stable and safe operation during all time. Maybe let's just pass maybe that one. All the examples I will just show to you are prepared because we have own lab and own production and own design. Vamtechnik is doing different projects. I mean that we have also small battery packs, which are just one cell battery packs. The biggest we produced were actually for the buses, where each battery was around 160 kilowatt hours, and that would be the application which we are talking about here. Just two examples. One of the most common, actually, automatic warehouse system in LFP technology, and LFP was chosen because we need to ensure the higher safety in the warehouses, and I believe that this technology right now is the best when it comes to home appliances. Also, we are doing some, let's say, challenging battery packs, but usually when you need higher currents. so we would talk about higher charging, for example, then we would have to switch to NMC technology, which has no such limits like LFP technology, and the limit is actually charging current, I would say. Currently, all the clients and actually expectations from the market are that we need to improve the energy density, and we need to have longest running time of the battery in any application. So I would say that's the challenge, because energy density and actually behavior of lithium-ion cells is stable when everything is okay. But if we will just go into some examples I will just present to you, then maybe we will understand better that it is very important to control the operation and have a complex management system, battery management system, that will ensure the safety of the operation. So here, in the first example, I hope that you can see the movie which is running. We have here the LFP cell, A123, very good one actually, and reliable one. I am showing you the nail penetration tests. Those are the tests we are doing in our lab to understand also the behavior of the cell and the technology. And as you can see on given example, it was fully charged cell and a cell that rested for at least 2 hours actually before I did the test, and we cannot see any fire. That's quite important for this presentation. Flame, no flame actually, just some fumes, I would say some pressure, but it was quite stable for the behavior. But also LFP cell, you can see that if we will just talk about the cell which was charged a bit more than it is allowed, it's actually getting not so nice. So we have a flame already, and we had very big pressure, and the cell was completely destroyed. And that's why I'm showing those examples, because here we charged it above the maximum voltage level, which is possible for the LFP technology. So in my opinion, the currents and actually the voltage limits are the most important when we are designing any battery and any energy storage system. Just for the presentation, here it will be an example of the NMC cell and the behavior. And I like to show that one actually, because as you can see, this is NMC cell, and we have example where also we do not have flame, we do not have any fire. And that's because this cell was actually charged to 4 volts. So it was really limited from the possible 4.2, 4.25 maximum voltage level for the NMC cell. So you can make also stable battery pack and safe battery pack in NMC technology. But most of the cells actually these days in all of the applications we have at homes are usually charged to the maximum level. And here you will just see what's the standard behavior of the NMC cell when it's broken, charged to 4.2 volts. So I would say most of the applications. So a lot of flame, a lot of fume, big pressure coming, and basically you can see that it's not a safe behavior, to be honest. So to sum up what I wanted to say, and actually what I wanted to show you, it is very important when we design the battery pack and when we design the power source to have this understanding about the charging voltage and also about the SOH, so the state of health. You have here on this diagram number 3. The information actually comes from one of the main cell producers, that reaching certain SOH, so state of health, also is giving us additional requirement that we need to again limit more the charging voltage, so we will ensure the stable performance of the cell, of the battery. And as you can see, this is quite important, I think, for the application we are discussing, because the cells that will come from the EVs and from the sector will be the used ones, actually. So we have to consider in the design that possibly we will have to limit the charging voltage, and we would have to get the good understanding sorry, for the SOH, so the state of health. It's good, actually, because right now the European Union implemented the regulation. It's called the battery regulation, and in this battery regulation you have some rules which are coming to the market starting from the August this year. And one of the actually key aspects is that all of the producers of the battery packs for certain categories, and actually industry category with more than 2 kilowatt hours, and that's the home storage system, will have to give you the information about the state of health. So in my opinion, it will be quite easy to control it and understand what's the current status of health of the battery pack. And yeah, that's actually from my side. Maybe it was just a short presentation and just some insights from the market, but I believe that understanding batteries, understanding chemistries, and getting those requirements into developing the systems, the battery systems, are the most important ones. So we will have the stable and safe operation. Thank you.
Yes, Philip, many thanks for your presentation. Great one, at least for me, because I have a battery pack here in my installation. Just we have, if you still have 1 minute, we have a question coming from the audience, which is related with these safety issues that you talked so much. Is from Sergio Lorenzo, is asking, how do safety issues influence the deployment of the post-EV cells in building applications, and what considerations should be addressed to ensure compliance with these electric codes and fire regulations? I know that you mentioned this new EU regulation about this. Does this regulation also applies to recycled ones, or any type of battery system? And also, I would like to know a little bit your opinion about the transportation of these battery pack systems, because it's not just installing and operating, it's just also to transport these packs for recycling. It's also a big issue, and we had this issue in our project. So I would like to have some of your thoughts on this.
Okay, so let's start from the end. So obviously to transport the batteries in lithium-ion technology, you need to have the UN 38.3 certification, and without that, basically it's prohibited to transport them. The certification it's maybe not so tough. I mean, it's quite easy to pass if you have a good design. I mean, the mechanical design, and also you have some protection system, which is usually the BMS. So it shouldn't be actually a problem to pass it. When it goes to post EV cells, I would actually stick to this thing about the state of health, because as I showed you, I also know a few engineers that tested the cells for many thousand cycles to understand the behavior, and usually those cells are quite okay, but we can think about them as a worn t-shirt, for example. So they will not have the strength which was from the beginning. And usually that's the challenge. That's why we do not apply the charging voltage, which is the maximum possible level, and we do not discharge them to 100% DOD, so the deep fault discharge, because this mechanical strength of the cell itself is a bit worn. Yeah, so I believe that we should apply some scenarios not to have, you know, the 100% DoD, and also limit the SOC, so state of charge. Yeah, but in a long term, I believe that's quite a good solution to use the EV cells and the modules from the market to different appliances. And actually, the battery regulation supports that, because it says that theoretically, each battery which is put it onto the European market should have the second life application.
Mm-hmm.
If it's possible, obviously. Yeah. From my side, I could speak actually, you know, more than an hour actually describing, you know, what has to be done to have such an application. Because in my opinion, you need to think about the second life application when you make the first battery. Yeah, because then you can think how to install it in the second application. Taking just the cells, maybe it won't be easy. The modules easier, but still we will have the problem that nobody would like to give you the know-how of the existing BMS in the EV application. Yeah.
Mm-hmm. Mm-hmm.
So then you need to have some kind of integration. So I believe that everything can be done, and EU is supporting that, but we still have a lot of question marks actually from the market, how we will implement this regulation in the meaning of this, for example, second life for the batteries.
Mm-hmm. Yeah, we should promote this eco design of the batteries, thinking on the second life thing. Okay, you're off, Philip. You need to go.
I got to jump. Sorry for that. I will have, you know, the everything turned on. So if you have some questions for the end, I will try
more or less. If you can stick afterwards, great. Because I would all love to hear it about also from operational environment conditions in this of these batteries in the buildings, which I think is also an issue. But okay, go ahead.
Thank you very much.
Many thanks for your participation. Okay, many thanks. Bye. So sorry for this changing of the agenda. We needed to act fast because Philip needed to go. Now I believe that Stefan from Flash Glass Association Germany will join us. Hi, Stefan. Sorry for this changing. Okay, I hope it didn't disturb you too much, but I had to make it quick and fast. So,
no issue, we are flexible.
Okay, great. So Stefan is going to talk us about glass and how multifunctional glass can be this building material, a very nice one. So go ahead, Stefan. Many thanks for your participation.
Thank you. So yes, good afternoon. Yes, I have to speak about the multifunctional material glass. So, in the beginning, my name is Steffen Schäfer. I have been working for the Federal Flat Glass Association of Germany, called Bundesverband Flachglas, and we was not part of this really interesting project. Okay, but I learned a lot of things in the first two presentations. Today, I will give you a short overview of our multifunctional building material glass and two topics which are currently occupying us. Hopefully, I can tell you a little bit something new. Here one slide about my background, where I'm coming from. I started in the building sector in 1996. First education as a carpenter, and then I studied architecture. At the same time, also the advanced education, the master carpenter. And then 2005, there was the beginning in the glass industry. First at the Federal Guild Association of Glaziers as a technical glass consultant for 5 years, and later than 11 years for HEC Interpain. There we was mainly responsible for with our team for technical project consulting worldwide and standardization technologies. And since last year, I'm working for the Bundesverband Flachglas. Now I'm responsible for the communication of standardization and technical issues which affect our market, our members, and so on. I try it because it's a big field. So that's one slide about me. And now one slide or two slides about our Bundesverband, so that you know, you learn what we're doing, what are we doing. We are the voice of the flat glass industry for many years, and completely represent the interests of flat glass manufacturers and processors in Germany. We have 3 pillars of the association work. We have the standardization technology, that's me. Then we have the political representation of interest. That's my boss, Jochen Grönegreis, and the public relations and marketing, my new colleague, Saskia. And we are also associated with the RAL Gütegemeinschaft Flachglas. That's a big quality label. Maybe a lot of you know the RAL labels. And we have it for the insulating glass and also for the toughened glass with heat strengthened, heat soak tested. So that is what we're doing in our house with a small team. And you find more information maybe later in the handout or if you follow the links on the bottom. Short about our members, here an overview about our members in and out of Germany. And here can you see also the location of our member and your project partner, Flachglas Sachsen. That's Mr. Witte asked me to do this presentation. I think I have not the time to speak so much about the whole details here. So, but it's important for me to say to you that we are open for supporting members, suppliers and or service providers, which can be also a member of our Bundesverband and can we can share experience and you have maybe also a little bit of advantages if you are a member. So if you someone is interested, let me know. So that's about the Bundesverband. About new interesting class products. So I've seen you have also used a lot of class in this project. So that's new requirements. So I couldn't decide which product or which application I want to present to you. And so I've decided to give you a brief overview what is currently interesting, what's moving the class industry or which products or applications are currently a big topic or becoming one. So class is an invisible but very multifunctional product. And as you have seen in your project also. And it's always has to be able to do more and more. As you tried also in your project, a new function. But what does it mean? The following two slides are designed to give you a small overview to the overview of the diversity of glass products. This list is only about coatings on glass. So maybe it's not completely full, but we will see. So e.g. you have the well-known coatings, thermal insulation, solar coatings, that's standard, but also bird protection coatings for generating electricity, anti-condensation, maybe also heating paints, radar reflection, self-cleaning coatings, nano coatings, etc. So there are a lot of different functions you can put on this glazing, or you have to combine it. But we have not only coatings, but we have also other requirements that glass can or must fulfill in addition to the coatings and all other technical requirements. We have the safety glazing, break resistant, bulletproof, sound insulation glazing, fire resistance, structural requirements maybe, switchable glazings, media facades, curved glazing, and also then in combination, that is a biggest issue normally, and combinations of the previously mentioned coatings, or maybe in combination with the new requirements which have you in this project. So that must be all in one product. So in Germany, we call this one eierlegende Wollmilchsau. That's a really tough product when you combine so many different things in it. So maybe also new requirements are coming with a new European building regulation in the next 1 or 2 years. So that's the reason I want to start not really with a product. I want to share with you this topic. As you can see, not a product. It's currently this topic occupying us, and it will continue us for a long time in the future. That's a sustainability. I heard it also some words, some slides before. New products, yes, we need new products, we need new ideas, but the glass industry, in this case, our industry, has to do some homework. We have to think more long term. We have to think about recycling or reuse. For example, maybe you have also considered it in your project. What is a glass doing afterwards? Can you reuse it? Can you recycle it? Can you remove the every part of the glazing and the other parts of the product? So to show you here, sustainability affects our lives in all areas, and sometimes, and the time is slowly running out. Low carb for buildings, yes, that's also something which we have in our industry some years now. The topic of sustainability is currently the most popular topic in our industry. That's my feeling, because every day I get the requests and we have to answer questions about it. In your buildings are responsible for around about 40% of energy consumptions and 36% of CO2 emissions, 50% consumption of natural resources, and also 40% of total construction and demolition waste. So what does it mean? It means what is the glass industry doing here? Glazing at the end of its service life is not collected normally. You know, you have the glass in the building or whatever and you throw it away. So what happens? That means in detail, only 10% of other flat glass waste is returned to the production site back. That means in detail, 45% will be downcycled into hollow glass, 30% is recycled as glass fiber and glass wool into the insulation materials, and 15% goes to the landfill. So 90% of flat glass is downcycled. And that is not what we want or need. Additional glass is in an energy intensive industry, and we need gas. Gas is the energy source of the production of flat glass, and it needs around about 1600 degrees Celsius to produce glass. This results in high CO2 emissions due to the burning of fossil energies, and the lack of the glass recycling and reuse of glass results also in additional emissions. How we can help? 2 or 3% reduced energy consumption per 10% cullet. So, but we need this cullet. That means 1 ton of cullet saves 1.2 tons of raw material, 310 kilograms of glass production, and around about 600 kilograms CO2 from raw materials which are not extracted. So it would be nice to have CO2 or low carb glass, low carbon glass. The conclusion, the glass manufacturers understand some years ago, due climate crisis and also due to the Ukraine war, gas crisis, to reduce CO2 helps the climate and helps also to reduce the energy. That it's a fact. So the recycling of flat glass is an important factor in our production. And so I think we need low carbon glass. Our flat glass manufacturer have set this target and realized it in different ways. And as always, with such new developments and new requirements, there's a competition. Who will save more CO2? You see it maybe here, one has more CO2 or the other, whatever saving. That's a big challenge, a competition, but it's not what we want. We try to help the industry to specify a specific solution for our industry, for the market, called the EPD, so Environmental Product Declaration. And we have done it for float glass, for toughened glass, laminate glass, and IGUs. In this case, we have average values provided by our members were used to obtain an industry average for the glass production. And this leads to the EPD for glass products. And also what we are doing is we have a working group for climate and sustainability with all glass producers, glass processors, and so on. We have also produced an information sheet for our members. That's really important in the market to have some information sheet to explain something in simple words. Because in this case, we explained the EPD in simple terms, how to read it, how to apply it if necessary, what values you get, and also how you can compare the environmental product declarations. It's really important because that's, if you don't know how you compare it, you cannot compare it. That's not possible. So some glass manufacturers already have their own EPD tools. Maybe you can have a check on the yourglass.com from HEC. So you can build some glass, and you get later, click on the button and you get an EPD for this. This information sheet, will be also published in English when we are ready. That's only about low carbon glass. That's also available, I think, since 1 year and you get it normally from all big suppliers. They find out new technologies to reduce the low carbon, what is really important for the future. The second topic I want to show is bird protection, a little bit different, because an issue with this has been with us for a long time, but has become more and more of a focus in projects in the last years, which large class surfaces over the last couple of years. And as you see in the bottom, in the USA, the requirement for bird protection exists also a little bit longer. Which probably also has to do with the fact that the amount of glazing has changed clearly compared to the past. You see, from the standard window, now we are on big projects, well-known projects in Hamburg and Berlin, where you have a lot of glass. So then could we have that we have an issue. Statistically seen, buildings are not the biggest enemy of birds. That's the cats. But unfortunately, still in the second place are the glass facades. For your information, these figures are only extrapolations from Institute, but you see that there is an issue, a big issue. So what is the use of it? In urban areas, we have a high density of buildings. It is particularly important to take steps for the protection of birds. Tall buildings attract a large number of birds and increase the risk of collisions. The implementation of bird protection solutions offers several benefits, including the reduction of collisions between birds and glass elements, which turns to help maintain the biodiversity. In addition, these actions can help to reduce the impact of wildlife habitat in urban areas. And second, the application. Glass in buildings is used in many different applications, as you see in the picture, such as glass facades, glass balustrades, window garden, or large windows areas, etc. In some parts of Germany now, we have also legal requirements on this subject, on bird protection. Or the building owners get obliged to observe bird protection for our own building. That I heard yesterday from someone who yes, they have to do something for bird protection. But what can they do? Birds have two problems, two big problems. That means the first one is a reflection. That's a mirror effect. When the bird recognizes the mirrored tree or forest in the facade and flies up to it. So that is a reflection. I think you know it. Every one of you maybe know that some bird is flying against the glass in the house or wherever. And it happens because of these two problems. The second one is the transparency. If the paints are highly transparent, here the birds may not be able to recognize that the glazing has been installed between the target and the bird itself. So maybe I can imagine that you can recognize the problem here. So and you have to check it. So for the project here, a short overview of the classic solutions which are currently available on the market. But there's also a development in from each supplier, and also in research from different institutes. A difference can be made between the solution between glass products solutions with coatings or etching, ceramic colors, foils, UV coatings, or different other things, and the constructive solution as an integrated solution, as you have something in front of the glazing, like a metal sheet or slats or whatever. On the following sheet, you can this QR code leads to a helpful information leaflet from Sempach Institute in Switzerland for birds, and that's really helpful. And to explain also some options what you can do if you get no information from others for the project, what you can do. We do also some via social media. So we have posted some stories about Instagram, about bird protection, and a lot of people come and ask for it. Hey, what can we do, and so on and so on. We have now here some products. The next two slides. The first is a transparent vision Onilux Mikado. Invisible for the UV basis, on a UV basis. Perhaps you can recognize the hardly, when you scroll a little bit down or zoom a little bit, you see a hardly visible structure. Arnold Glass is in our eyes it's a company which is the most experienced on this topic since more than 30 years. As I start with it, and the second product which I want to show you are from two PVB foil manufacturers from East Vancouver Array. They have also some things between the glass paints and the foil in the foil integrated. So that's tested products, and what I mean tested products. That means all products which has to fulfill the requirements, has to show or has to be tested. In worldwide, we have, I think, only two test stations. One is in US and the other one is in Austria. In Honau, Engineer Martin Rössler is here the boss, the expert. And we are also still in contact with these guys. But it must be tested. The slots are really limited. So it's not possible to do every day thousands of product tests. No, that's really limited. But the experts and the product industry try to find solutions now. And we try also to find solutions, and that we have also a Bundesverband a leaflet, a bulletin. It is in preparation, and it deals with the requirements and possible solutions. And we are also in the best case scenario, we find exchange rules. So that would help in the market, that we can change something in the product. So it will help to that it is also it will be tested, and it is a highly it will work. That is what I want to say. So we are close in contact with these experts, with Mr. Rössler and the other one in these test stations, and we try to find solutions here. I have also a lot of few more products, but unfortunately we do not have enough time. However, I will provide you a handout. Here I will mention the topics, including the manufacturer and the links. Maybe it's interesting for you. Okay, we heard of the new things about vacuum glazings. Vacuum glazings are normally from the Asian market. Now we have since some years vacuum glazing production in Europe, in Belgium. That's called Fineo. And so you get it much cheaper, and we have a new technology behind. Then we have the radio transparent glass. That's also really important for the big for buildings. So if you need the 5G standard, that is not possible with a low E coating. That is not possible. So maybe you need a radio transparent glass. I have seen you have also the building integrated photovoltaics. So it's also a big issue and a high technology in the future. And then from other points, the curved glass possibilities, new possibilities. Maybe it's done by the Fraunhofer Institute. It's really interesting. New technologies. Oversized glass is also, maybe you get now glazings from 3 by 20, 21, 22 meters. And it's also built in some buildings in the world. Oversized glass coating. Then we have coating on demand. So architects can find their own coating on a glass, and you can get it in one plant in Germany, and then you have your own coating. Then the anti-reflective glass is not so new, but it's also really important, I think, also for BIPV. And also laser technologies, you can do a lot of things with laser technology in glass. So, and if you have any questions later, please feel to send me an email. So that's the foils. I will go through the foils a little bit. What I can show you here for vacuum glazing, it's Fineo Vacuum Hybrid. That means you have one vacuum glazing, and on the other side you have a coated standard float glass, and you can get with a double IGU and UG value of 0.4. That's really interesting, a new product, and it's also available in the DACH market and Belgium, Netherlands, and UK at the moment. Radio transparent glass, okay, I've told you there's a BIPV. New possibilities of curved glazings. You see there are also that's based on laser technology. Also really good, really nice. I've seen the prototypes, and they're also possible to do it in windows for the whole glass edges and so on. And here are some new other class projects for over that class, and you see I have put some links in it, so you can share it. And if you have some questions, let me know. So in the end, finally, here's our homepage. And if you need need some information about the class or about our BF bulletins, you can go on the downloads and you have everything here for free. Follow the QR code, that's fine. And yeah, please always be open for new ideas and stay curious, think out of the box. Thank you. And I wish you a further existing presentations and a nice weekend. Thank you.
Hi, Stefan. Many thanks for your presentation. Great insight. Probably we should have much more time to hear it from you. And great that you introduced the sustainability approach to the glass development.
Mm.
Also, great to know there's new technologies for this bird protection. We could use it a lot here in our facilities. Great to know. I know that we have a question for you. Probably you can give some insights. It's from Anna, and she's saying, "Hi, Stefan. Looking ahead, how do you foresee the evolution of multifunctional glass materials in building design and construction, considering advances in smart technologies and efficiency requirements and architectural trends?" Basically, I think this question from Anna, it's a good one, and I would try to focus a little bit more on how do you see the construction marketing responding to the introduction of these novelties, of these novel multifunctional glass systems. And how do you sense the market? What are the factors that are influencing its adoption or resistance for the construction sector? All these new novelties that you showed in the last slides, which are really exciting. But is the market ready for it in terms of cost, acceptability, building codes? How do you sense the market in this regard?
I think that's a lot of questions, but that show what happens in the market. You have so many requirements. So then we have a lot of people, architects, which have a lot of ideas, and then we have a lot of research institutes which have also a lot of ideas and research projects, and then new things to develop or to implement new things in our building industry. It's not an easy one, but there are possibilities. Not directly maybe in the standard, but you have also possibilities in Germany with the DIN spec, for example. So you can implement a DIN standard, a really quick one. That's a special of a DIN. And also with ETAs or something else, you can implement new things. And for me, the important thing is that the research, the architects, the producers, everyone has to communicate about it.
Yeah.
So because I have in the past, I learned about a lot of new products which are still not on the market because there was really good products, really good in research, but they don't talk to the practical part. So architects or the buildings or something, they don't talk to her, and then it comes to the buildings that it doesn't work. That's shit. So in real, we have to communicate everything really early stages to have the requirements. I think for a lot of different applications, we have solutions. Important thing is to combine what I have shown you, to combine everything. That's normally the biggest issue. You see, we have we want to have daylight in this, also big issue, daylight in building. So high daylight means high transparency. So high transparency is something worse for the bird protection. So that doesn't combine. It's a target.
Combine.
A target.
It's a difficult balance.
So on that we have a lot of examples, but in the end, yes, I think we are well prepared in the production side. We have a lot of producers here. See also Mr. Witte from Flachglas Sachsen. He's also really interested in new things.
Yes.
So that's totally nice. And communication is the best one to solve the issues.
Okay. Many thanks, Stefan. I believe that you also need to go.
Yes.
Yes. Sorry. So probably we will not use the question and answer roundup in the end. So if any question pops up for you later on, I would keep it and I will send it to you, and you can answer directly to the person Okay.
Perfect. I will do. Okay. Thank
Okay.
you.
Once again, Stefan,
Was
many thanks and all the best for your work.
also nice weekend. Bye bye.
Bye bye. So, tight schedule. Many people. It's a Friday, so it's difficult to combine all the needs of everybody. I would go for the presentation. Move forward for the presentation of Roel Lonen. Hi, Roel.
Hi, good
Hi.
afternoon.
Sorry for all this mess with changing speakers and everything. I hope you are safe in this regard. So go ahead. Raul will talk us a little bit about simulation tools for energy efficiency buildings. It's a pleasure to have you with us. Raul, take the stage.
Yeah, thank you very much. I think I will try to keep it a little bit shorter. So the topic today of my presentation is about simulation tools, and specifically also in relation to the previous presentations, how we can use them in research and development of innovative building envelopes. I work at Eindhoven University of Technology in the Netherlands in the Building Physics and Services group. So what I observe is a lot of challenges that we have and many reasons to get very sad and upset. So really an urgent need to change the way we build. At the same time, there's many opportunities, many new ideas, potential. I think the future looks very bright and optimistic. It's just a matter of choosing. So we have lots of different technologies, different options. The question partly becomes which one to pick, how to be sure, and how to minimize risks. In this context, it becomes, I believe, increasingly important to make informed decisions. Weighing different alternatives. There's not going to be a one size fits all solution that works for all the buildings. I think that's also what we see in the Powerskin Plus project, actually. And especially there is this need for making balanced trade-offs. Sometimes we have competing requirements regarding comfort and energy or emissions, and how to balance those. So this is where my research focuses. It's on bringing this all together in using modeling and simulation methods, often with a focus on optimizing the indoor environment, creating conditions that are favorable for comfort in the first place, but closely related also well-being and health aspects, and really tackling these from an integrated perspective. In many of the projects, we do this using modeling and simulation. So I think most of the people in this room here, they either work with or have heard from tools like Energy Plus or Transys, IDA ICE, ISVE. There's many flavors out there. In the first place, they are used for actual building design projects, showing compliance or helping in early design stage decisions. Also in some projects, and that's what I'm going to show you after, we can actually use similar types of models in product development settings. So really helping innovation teams to sharpen their proposition, to find out what does not work, to try out products or combination of products in different climates or different building types. And I've been doing this with a bunch of different companies, often with this aim of what we call bridging this valley of death. So helping to go from a situation at low technology readiness levels, where there is a lot of attention for the research aspect, to the high technology readiness levels, where we really care more about commercialization and making sure that new ideas actually land in the real world. So in the rest of this presentation, I would like to show you one project in detail. It's an ongoing project that we are still working on together with project partners, primarily Pilkington and TNO here in the Netherlands. And the idea is it's related to BIPV in, well, transparent parts of the envelope. So what we have is double or triple glazing solution with PV cell stripes. What makes it interesting about these PV cells is that they are bifacial. This means that both from the front, so that's the part that's facing the outside, and from the back, they can generate electricity from the light they receive. Normally, this backside effect is not so relevant for this type of facade applications, but here the idea is then to combine it with a Venetian blind system. In this case, a Venetian blind that's integrated in the cavity of the glazing. And then, yeah, what's the main proposition here is that when it's very sunny, there's a high risk of glare. We would close the blinds. This leads to reflection of light back to the outside, but also to the backside of the PV cell to give an extra boost on the amount of electricity that can be produced with such a system. So in this R&D project that we are in, we are bringing this from a conceptual idea to hopefully as close as possible to the market by the end of the project. So for part, we are in our outdoor testing laboratory at the university. We are measuring the performance of different types of prototypes. So here we talk about different coverage ratios of these PV cell stripes, but also different reflective properties of the slats, different control strategies of the blinds, so different angles. In the lab outside, we primarily try to understand then the electricity harvesting potential, so the solar cell part of it. But in parallel with this, we are using modeling and simulation to really understand the impact on occupants that would live in or that would inhabit rooms after or behind such a facade, trying to find a good optimum between glazing properties, PV cover ratio, blind properties in relation to, on the one hand, the energy balance of this building, so both energy consumption and energy generation potential. On the other hand, also thermal and visual comfort inside the spaces. And for this, we use modeling and simulation at two different levels. The first level is what we see indicated here. So that's more what we call the component level. So really trying to characterize light transport in such a system. So using ray tracing methods to really find out, okay, of the incident light, where is that going? How does it work in relation to the slat angle, for example, direction of incoming light, both to see the amount of light that then enters to the inside, but also to see the light that gets reflected back onto the PV cells, as you can see here indicated in the middle figure. And then once we have such a characterization, we can also then export this into this type of reflection, absorption, and transmission curves that can, on the one hand, be used to compare to performance of alternative systems. On the other hand, also serve as input to building level or room level simulation models. And this also requires sometimes a little bit of tweaking of actually the code that is behind these simulation models to be able to let them to work with such novel technologies. Then we integrate that in a framework like you see here on this figure, where we can really see both the thermal and the daylight aspects and their interaction in relation to the fenestration system and the control strategies. So you can imagine that it's very important to come up with advanced enough control strategy that really knows when the blind should be up or down, or in what this angle of these slats should to be able to indeed minimize emissions of the building while optimizing comfort. So this is still work in progress that's going on at the moment, but we recently got some daylight simulation results that I show here on the figure that I know sees a little bit messy. But we can look at different indicators such as the daylight autonomy, which expresses basically the amount of light that comes in. So higher would be better here. And then for different configurations, coverage ratios, we can understand if there is enough light or if there's too much priority given to this solar cell part of the picture. In the same sense, this useful daylight autonomy then gives us a balance also between having enough light or having too much light, where we see that values in the middle ranges here seem to come to the best performance. So what we are doing right now is extending this also to the thermal simulation part, and then really working on, as I mentioned, these control strategies to optimize different concepts for different climates, trying to further find this balance that I mentioned between competing performance aspects. So if you would like to read more about the role of this type of modeling and simulation in product innovation, then I would like to invite you to check out these two papers that I have here on the slide. And with that, I actually come to the end of my presentation. So if there are questions, I will be happy to discuss them with you.
Okay. Okay, Raoul, many thanks. Quite interesting presentation, because we are actually working on similar stuff in different projects. It's quite nice to see this building integrated photovoltaic systems that you are working with. I would not pose you directly a question regarding specifically this type of work, but I was wondering if because we all know that sustainable high performance buildings obviously involves the design of environmental responsive structures and process. And typically the classic building design tools concern more issues such as energy efficiency, the PV generation capabilities, human comfort, visual, to meet the building codes and all the standard requirements. We all know about LCA tools that are specific for sustainability, but is there any tools, sustainable performance simulation tools for building design that are matching the ones that you are working with, or energy efficiency and thermal comfort is one thing and sustainable performance simulation is another completely different scope? Is this trying to be mixed somehow or not?
Good question. So that there are some efforts that combine the let's say the LCA calculation or the environmental product declarations regarding embodied impact with the operational impact, so the emissions that have to do with heating, cooling, ventilation, lighting, etc. But what I see is a lot of this is still very much in the research domain, and in the let's say compliance-based calculations. Up until now, they are still very much separated. But I think we see positive signals from the new EPBD that is coming up, the new version, where more and more integration between these two, so the operational part and the embodied part, will happen, because ultimately they are pointing to the same thing instead of treating them as two separate fields. So I think this is very optimistic. At the same time, yeah, these processes tend to be slow, and I think we'll need to wait a couple of years before that's really there, because the legislation ultimately is what's driving also not the innovation, but a big part of the market actually forward.
You're right. You're right. Okay, we have another question from Bruno in the chat, but I would invite Roel if you could answer this in the chat to Bruno. Okay, it would be great, because we are a little bit off schedule already, so we need to move forward. Many thanks, Roel, for your nice presentation and great work. It was really
Thank you so much.
insightful. Okay, many thanks.
Thanks. Bye bye.
Oh. Okay, we would move to, I believe, Robert. Hi, Robert. Robert Anish. I don't know, Robert, if I can pronounce your name correctly.
Hi. You're close to it. Yes.
Close to it. Thank God. Okay, so Robert is going to talk us about vacuum insulated panels from Turvac, which is a great topic for me to hear it from you. So many thanks for your availability, Robert, and go ahead, please. The floor is yours.
Thank you. Hi to all who are still with us on this late Friday afternoon. So I'm coming from Turvac company, which is the part of joint venture of Recticel Group, which is Belgium company, and Turna Group, which is Slovenian company. So we are part of VIPA Association. That means Vacuum Insulation Panels Association, which is the, leading group who associate every, important producer of VIP or its components like foils, silica, and so on. If you go further, so we are currently in the phase of spreading our facility. That means we are going for 4 times higher capacity. And this really shows you how the VIP panels are really important now in the several industries like cold chain industries, so transportation, cold packaging. Then you have various pharmacy, medical, and so on. Then you have construction as such, and also some OEM applications, which are really growing up. So this is our new facility in Slovenia, in Europe, center of Europe, let's say so. And this is really nice insulation comparison. So maybe here is missing one I didn't add, but if you look EPS and XPS, so you can find in this range of 30 to 40 milliwatts per meter Kelvin also mineral wools like glass and rock mineral wool. Then you go to polyurethanes around 25. You can find also some other applications like pier plates. But then you go to aerogels, and then it comes to finally into the panel. I call it for us Turvac panel, but also there are other vacuum insulation panels. So we are in the range of 4.5 milliwatt per meter Kelvin or lambda. So if you vented that, so you are losing the vacuum as such, you will still get it around 18 milliwatts. So it's high efficient insulation, but then you need a bigger thickness for making R and U values. Yeah? Okay, if we go forward, so where we are now, like I already mentioned, we are in construction and building. We are in temperature control packaging and original equipment manufacturer, so OEM business. So you can see that we are huge partners with some fridge or ovens producers. So this is exactly the case how you can build one pharma transportation box where you are adding, let's say it was really popular, and this was the only way how to handle the all vaccines for the corona effect of corona, where you had these all vaccines from the Pfizer and all others producers. Yeah? So here you can hold them for several days, not hours, days, at a certain temperature. You can have it minus or plus. It depends what you want. Yeah. Then also you can go how we are doing the product range. So you can have, we're mainly using as a core fumed silica. So this is the silica which is in microns, or we call it some microparticles. And these microparticles are done in such a way that they have microporous holes. And these holes is air. And during the production of the whips, you can push this air out and you get the hollow structures, and when you can put, how to say, you are vacuumating that holes. Yeah, so that's the reason why you're getting so good panel with low lambdas. Yeah, there are several options that you can also combine them with some polyurethanes. You can combine them with some cellulose adhesive foils and so on. Yeah? So there are several combinations. Also, you can make some other things, like this is how the box is produced. This is whip box, and then you're implementing it into the one plastic one that is more, how to say, protected, that you are not ventilated them. Then you can make it like insulation of some terraces. You can make it insulation of the flat roofs. And this is the product itself. We call it deck vacuum. So you have PIR plate, so polyisourethane plate, which is as a cover for the whip, which is inside. You can make it different shapes, like cubit, trapezoid, custom made. You can make it as well holes in the whip. So it's possible, especially for OEM producers. And why we have such a uniqueness? If you want to say so, you can let's say you have here a case that if you are producing like box having a PU foam, so polyurethane foam, which is 60 millimeters thick, and you can get 440 liters of the space. So if you add into that one of the whips, you can gain 25 millimeter less thickness, and you can combine PU foam plus whip. So you will get 66 liters additional. So this is exactly what is the catch of the whip. So you can make space-saving designs. And this is not just for boxes, it's all over. You can make it in construction. So imagine that you have one mobile house where you are with strict regulation, which are coming more and more, demanding like 100, 150, or even 200 or 300 millimeters of insulation on conventional ones, on Express, UPS, mineral walls, and so on. And then you say, okay, this is not anymore logical, because if you have some mobile house with 50, 60 square meters, you will lose crazy a lot of. So if you go with whips, you can gain like 4 to 5 square meters additional. And this is already your toilet, washroom, shower, whatever is coming in this mobile house. Yeah. So really, this is the opportunity how you can save and still get the same efficiency. Also, if you have some special things, like we are transferring from Europe to Asia for one aerospace things, one special glue, or how to say special polymer, which is caused, and in this insulation with whips box, we can catch up delta T less than 10 degrees in almost 1 week at minus 80 degrees. So it's huge, how to say, energy saver, plus you are not losing it. Huh? And this is the main opportunity how the whips can be implemented all over different applications. But from my point of view, this is just a beginning, because the whip as such in the area of industrial or normal life where we are doing it, it's just becoming. Of course, it's a niche product. You must to take care of it, how you're handling them to not lose the vacuum. But there is much more opportunities there to come. Yeah, so I'm fully optimistic on that. Okay, Also, just to mention, if somebody's interested, we are also the competent center for the VIPs for our Recticel and Turna group. Plus, you can also use our services for all others. So we have really, in this new building, we have really modern testing facilities, and especially what is most important is this reaction to fire test, all mechanical tests what are needed construction, especially aging test, because everybody was asking, okay, how long it takes, how long the VIPs can survive and so on. If you're handling properly with them, you can get 25 years minimum, yeah, of usage, and this is for construction way ahead. So that's on the laboratory, and I'm almost on the end. So thanks for listening to me. And if there are some questions, I'm ready to answer.
Okay, many thanks, Robert. Great to know about your company. I would like just to ask you something. So
Yeah.
we all know that VIPs are still, as you told, a very niche market, especially when it comes to building construction, due to factors such as price. For instance, the installation burdens, it cannot be cut on site, is very easily punctured, so it needs a very specific and demanding installation.
Yes.
And they must heavily rely on design preparations. But
True.
I truly believe that the modular prefab market might be one that might take the best advantage and welcome this technology. So have you been approached by the modular prefab market from panels where you can on-site install this vacuum insulation technology much easier, because it will be off-site, it will be in the industrial controlled facilities? How the market is doing at this point regarding this approach? Can you tell us your knowledge about this?
Sure. Yes, there are two things. Yeah? So one thing is that if you look at the normal construction market, there are people, they don't care about handle with care. Yeah? Let's say so. So you know what I mean. So they're walking on that, they're throwing around and so on. This is not how the VIP should be treated.
I know.
And the catch is that so what is our first approach to the construction market? It's the prefabricated elements. So the catch are those mobile homes, the catch are the panel producers. We also now Recticel group, maybe you know the company Trima, which is quite a huge producer of panels, and we are developing with them a few products as such. So when with applications where the VIP is as such can be protected, then, and you have skilled persons by us mainly, how to handle and how to attach or how to apply into one element, prefabricated one, then it's easy. And this is the area where it's really going in huge direction. There are also some reconstruction things, like you seen, we developed one deck vacuum and we already protected our VIP. So those deck vacuum products are like 45 or 60 millimeters. So it's really thin, and you can really get option how to insulate. And they are having 6 milliwatts, let's say lambda. If you will do your reconstruction with XPS, CPS, or with mineral walls, you will get much more. So it's not efficient. At the end is the price as well. But if you look that you're reconstructing something in very expensive areas, it's much. It's so investment is higher than with normal commodity installations. But if you look that you are gaining more space, it's coming back in, let's say, short time. If you look that you are renting 1 square meter in the middle of the Paris or in London or somewhere, the VIPs are coming huge fast back. And also you can also have issues with some historical points. That if you go to so there are demands: renovate, saving energy. and then you're coming again into the London or Paris, and you're saying, okay, I want to make insulation in the front, like the people with commodity insulations are doing. They will say, no go, I want this Baroque style to be seen. I want, imagine Versailles that you're insulating it now,
Yeah.
Forget it. You will do it from inside, not from outside. And if you will do it from inside, you must to get the space, and you must to not lose the space. And this is the VIP, the right solution. So things like that are really coming up and popping up, and those are those niche things. But if you look now in all these areas, especially in cities, renovation is the only insulation, which is happening, and things are popping up more and more. So
great to know
I
it.
really believe in that, and this is our future if we look like that. But we will never be, let's say, fully competitive to some huge like 100 tons lines per day and so on. You know what I'm talking about. So.
Yeah. Okay, great, Robert. I believe that there's also some comment. If you can just answer in the chat, it would be great. Okay, because probably we are skipping the Q&A session roundup in the end because it's too late already and we still have two speakers. But many thanks for your presentation. Probably we will talk later on about some different encapsulating materials for your VIPs. Probably I can have some ideas also to discuss with you. Many thanks, Robert, for your availability. Okay, many thanks.
Take care. Bye.
So we move rapidly to Callum. Hi, Callum.
Hi.
How are you?
I'm all right.
Sorry, this is the very late Friday already.
Don't worry, I've got nothing better to do.
Okay, great to hear that. Okay, so Callum will give us a very interesting, I believe, presentation, at least a little bit more disruptive, regarding the biogenic materials in construction and how to understand the role of sequestered atmospheric carbon. Callum, the floor is yours. Many thanks for your participation.
Yeah, thank you very much. Just a quick note to say that I'm presented in the program as being a member of the Norwegian Institute of Bioeconomy Research, which I have an affiliation to, but I'm here today representing my consultancy, which is JCH Industrial Ecology Limited. So if you want to contact me, you can find me on LinkedIn or just type my name and then JCH Industrial Ecology, and that will take you to me. So I did some work quite a few years ago now for the United Kingdom Climate Change Committee with a number of co-workers, and we were looking at the role of timber in construction, and I was very pleased to see that there was a presentation earlier where timber facades were considered, because I felt a bit on my own really when I saw some of the other topics. So that was interesting, and I did work on a project many years ago called IO, where we were looking at prefabricated insulation panels, which involved quite a heavy use of biogenic materials. When we did this study for the Climate Change Committee, I was very insistent that we factor out the emissions and treated them separately from the stored carbon in the timber. Timber obviously comes from trees, and trees very obviously absorb carbon dioxide to grow, and that carbon, the atmospheric carbon, gets embedded within the timber, and during the duration for which a timber product is used, that carbon is stored. So it's a carbon store. But it's very important that we treat emissions and storage separately, which isn't always the case. There's been a lot of publicity about the use of buildings as a global carbon sink, and buildings are very useful from this point of view because they're very easy to see. It's very easy to measure how much material is stored in the buildings. But the trouble is the rules that currently run in life cycle assessment and the rules that are used in environmental product declarations use this so-called -1+1 rule, which basically say that they follow the flows of carbon through the whole life cycle, and that atmospheric carbon, although it gets absorbed during the growing of the tree, It's stored in the building, but at the end of life, it's treated as being emitted back into the atmosphere. So the net result, according to that particular methodology, is that there's no benefit whatsoever from the use of biogenic materials in construction. The problem with such an approach is that although the maths adds up, it takes absolutely no account of the time of storage. And this is always the problem when you do an LCA analysis of a single product or a building because of this rule. There are other approaches to this, such as dynamic LCA, which I'm not going to go into. But the main problem with such an approach is that we're dealing with a single product. And really, we should be dealing with a population of products. We should be looking at how much carbon is stored in that stock of products, the same way that we would work with a forest. Now, as part of my activities within Nibia, I did do a presentation quite some time ago to Norwegian students, hence the use of a map of Norway for this. But basically what we're looking at, rather than looking at an individual building, we should be looking at a stock of buildings in a region or a country and draw a system boundary around that region or country or whatever that system is that we're trying to analyze. So it has to be a population of buildings because we are looking at a dynamic flow of that system. And it seems obvious that a stock has an inflow and a stock has an outflow. And we can have analogies that we consider a bath where the plug is out and the tap is on. And obviously, if the tap is running faster than the water is leaking out of the hole in the bottom, then the bath is going to fill up. And similarly with a balloon, if you fill up a balloon, it's got a hole in it, and you blow harder than the air's coming out, the balloon is going to fill up. And these seem like trivial, childish examples, but it's very interesting how people mix up stocks and flows all the time in this subject. Again, it should be self-evident that if you have a stock and a flow into that stock, the stock is going to be stable if the inflow and outflow are the same. So if we measure the size of that stock over time, it is stable. So that is a stock that is in equilibrium. So that would be a situation where the number of buildings in a population is stable. We are demolishing buildings at the same rate that we're building them. However, if we have a situation where the inflow into that stock exceeds the outflow, then that stock is going to increase. So that situation would be one where we are demolishing buildings at a lower rate than we are building them, simplistically. And similarly, if we demolish at a faster rate than we build them, that stock will decrease. So this stock represents a carbon flow into and out of a building pool. So now the inflow, excuse me, I need to go back to the other slide. The inflow, the problem with that slide is that it doesn't have a graph with it, and it used to have a graph with it. The inflow is treated as being constant. And in this model that I'm going to present, we just put a number on that. And we say that we have 1 ton of carbon flowing into the pool every year. Then we have to model how the carbon flows out of the pool. And in order to do that, you have to model using a decay function because we're looking at a population. So over time, although the carbon has gone into the pool, that carbon will slowly leak out of the pool and back into the atmosphere, but not immediately. It will follow some sort of decay curve. And the default function that the IPCC recommends, if you don't have any evidence to the contrary, is to use an exponential decay. And I'm going to explore the consequences of using an exponential decay compared with other decay functions in this talk. Now, the problem with an exponential decay function is that it assumes that from year 0, you are going to start leaking carbon out. So that means that essentially your building stock is going to start being demolished right from year 0. And that's not a very realistic assumption. You can have other decay functions. This one shows a sigmoidal shape, and it shows that over time, the population will leak carbon back out of the stock into the atmosphere over a time period. And the length of that time period is determined by some sort of statistical function that measures an average time for buildings to exist within that building stock. So it would rely on historical data if that data existed. And we can have different types of function, and we can measure their probability and their cumulative distribution, and the shapes of those functions we can also vary. So if we start with a model where at time zero the stock is zero, and we have an inflow of 1 ton of carbon per year into that stock, and we have an outflow that is determined by the, excuse me, seems we're getting some blank slides for some reason, and we have an outflow that is determined by a statistical function, then if we look at the effect of doubling the lifetime of that building stock, the average lifetime of that building stock, we find that the carbon stock doubles in size. Very strange. Right. Okay. We can also look at the effect of cascading of those products from the first life to the second life. And here, if we look at a fixed half-life and a variable proportion, so we're using a decay function which is based on it's purely a normal distribution. We're looking at a fixed lifetime, and we're looking at a variable proportion that is cascaded down. For this particular case, the half-life is shown in the table below, which is 30 years, so that's stable, but we are cascading different amounts into that second life, and we can look at the effects of cascading larger quantities of biogenic carbon into that second product. And the result of that can be seen in this graph, that you do have more carbon stored. But actually, even when you are cascading quite a large proportion of that material into a second lifetime, the amount that's stored doesn't increase hugely. However, if we increase the lifetime of that second life product, and we use a standard amount of material that's cascaded, this actually has a much greater effect. So the result of that is basically that lifetime extension is much more important, and the benefits of carbon storage can only be determined by using a materials flow analysis. It doesn't work very well if you use life cycle assessment. And if you're going to use life cycle assessment to prove the benefits of circularity, it's not that simple, because there are many, many factors that you need to take into account. Right, okay. I have to say that is the talk I was expecting to see. So I've got a completely different one up on my computer. So that threw me a bit. I think that's the one I uploaded yesterday as a practice. Okay, I can only apologize for that. That's the end of my talk. Thank you very much.
Okay, sorry, Callum.
I thought the other one had been uploaded. So
yeah, I don't. We probably would miss the different application.
Yeah,
but
because
anyhow,
I went through it and I thought, oh, that's all right, but I should have gone a bit further in the slides. So
yeah, anyhow, it was great because you
No, it
showed
wasn't.
us a completely different perspective of what we are normally focused on with these LCA approaches, and great to know about this issue of life extension, which being the most important thing when dealing with this type of materials. I'm not very acquainted with with this line of approach, so I would try probably to seize the opportunity to ask you something more or less that I would like to ask to Ricardo, our first speaker, because you are also working with timber structures and these biogenic materials. I've been reading some recent studies on how if we substitute this wood for conventional materials for this wood, timber-like wood material, we could reduce a lot the emissions in the building construction. And in new urban constructions, there could be a potential to achieve 9% of the 2030 emission goals, which would be great. The thing is that actually here, for instance, here in Portugal, we're very used to think about timber materials in construction of single family and small units, single family buildings. And these are very limited in urban areas where this new low carbon construction probably should prioritize larger mid-rising or even high-rising buildings. And when I'm talking about mid-rising and high-rising, I'm talking about both residential and commercial buildings, which are a great part of this retrofitting action that we all need to take.
Yeah.
Obviously, that there are technical issues of working with wood compared with more conventional construction systems. But don't you think it's a little bit more reflective question, not a direct question, but don't you think that there should be some sort of promoting the incorporation of this mass timber in building codes in order to implement more effectively this type of construction materials? Should building codes promote somehow the usage of these biogenic materials much more than they actually do, or through implementing some carbon credit incentive programs? Don't you think that there are some roads still to work out in this sense in order to bring these materials a little bit more upfront in our market? I would like to hear some reflection from you.
Yeah, I mean that's quite a lot to unpack. I mean, there is certainly resistance in the industry to adopting unfamiliar technologies, and people are very used to working with certain types of material. They, insurance companies are used to working with certain types of materials. So there's a lot of resistance in the industry to adopting new technologies, which may have perceived problems. They may or may not be real problems, but they may be perceived. And it isn't helped by industries that feel threatened by the introduction of, let's say CLT in mid-rise and high-rise buildings. They're going to do their best to protect their markets, which is their job to do it. And that doesn't really help, doesn't really further the debate, because we do have some very serious issues that we need to deal with. And I don't think the industries that feel threatened really need to feel as threatened as they do by the introduction of these new technologies, because I think in a growing market, there's probably room for everybody to, have a slice of that particular market. But yes, that there are issues, particularly around sort of legislative topics that are preventing the adoption of CLT, particularly in mid-rise. I mean, there's some quite famous high-rise examples that have gone up and got a lot of publicity, but for the lower sort of mid-rise sort of in urban environments, I think that there's still quite a way to go there, and it's not really tied up in Europe in a standard way. There's some countries are promoting these things more than others, and of course some countries have got a very strong timber culture, whereas maybe Portugal, it's not seen as such a
good market,
desirable material to make.
Yes. Okay, great. Many thanks for your presentation. Great one, and sorry for this problem with your version.
Well, I uploaded one last night, but it was only to practice the upload.
Okay, but I think it was very insightful, and I don't know exactly if we've got some questions also in the comment section, but please try to review it and give it some answer to it, because meanwhile we need to move to Maria. Otherwise, it will be already nighttime in Greece.
Yes. Okay.
Okay.
Right.
Hi, Maria. Nice to see you. Not yet. Oh, now I see you. It's always a pleasure to see Maria. Hi, Maria. How are you?
Fine. I hope you can hear me.
Yes, loud and clear. Sorry for the delay. Hopefully,
It's
you're
okay.
not too much tired. And Maria actually is a partner in different research projects, sister projects, funded projects by the EU. And she will talk us a little bit about two, the Plural and the Green Nest projects. They are dealing with prefabricated envelope solutions for zero energy and zero emission buildings. Maria, it's always a pleasure to hear it from you, so go ahead.
Thank you very much for the introduction. I know that I'm the last one. I don't know if I can change. Yes. Okay, good. I'm the last one in this very interesting session, and I will try not to be very long. Well, I would like to start by taking you back to a very basic question. Why is renovation towards near zero energy buildings and zero emission buildings important? We already heard earlier today that the EU the Parliament just a couple of days ago approved the recasting of the EPPD to include a new dimension which aims to progressively reduce greenhouse gas emissions together with energy consumption in the EU building stock to make it climate neutral by 2050. So the new regulation requests that the new buildings should be zero emission by 2030. And in this definition of the zero emission building, we should take into account the life cycle global warming potential of the building. So from now on, we should not only talk about reducing the operational requirements for the energy of the building, but also looking at the emissions that are emitted from a building and a life cycle perspective. My second question is, why do we promote prefabricated construction, off-site prefabricated construction? For several reasons, which you can see on this slide. First of all, this type of prefabricated systems or kits can allow to produce solutions that are adaptable and tunable to the requirements of each building typology towards both the NZEB and zero emission targets. They allow to improve both production and resource efficiency in new constructions and in renovation projects. They provide higher performance and resource efficiency, both in energy and material. Of course, it is well known that this type of construction is faster, reduces disturbance of the occupants, reduces waste on site, and supports the user-centric deep renovation approaches. They are more cost-effective, and there is the potential through the construction practices to reuse both the building materials and to go towards urban mining. And last but not least, prefabrication is compatible with construction 4 principles such as BIM, point clouds, digital twins, material passports, and so on and so forth. So this is the combination of the key topics that I would like to address in the frame of the two projects that I'm going to briefly present to you. The first one is called Plural. The title stands for Plug and User Innovation with Adaptable Lightweight Systems. And the second one is called Greenest, which is a Nest ingrained ecosystem for zero emission buildings. As you can probably understand, the Greenest project is it's built upon the experience gained through the Plural project. So let's go on. Let me very briefly introduce to you the Plural key objectives. The Plural project, which is now at its 4th year and it's going to end in September 24, aim to design, validate, and demonstrate a palette of adaptable, scalable, off-site prefabricated kits, which we call plug and use, PNU. It's a paraphrase of plug and play because we take into account the user, the tenant requirements. And the challenge here was how to identify, select, and integrate various renewable energy technologies and incorporate them into prefabrication practices to create adaptable, multifunctional facade components. So we ended up with hybrid passive and active facade systems that operate in one kit and are able to work together in synergy for facade retrofitting, ensuring near zero energy buildings. So we ensure NZEB status, fast-track renovation, cost-effective renovation, environmentally friendly deep renovation, and of course, flexibility and adaptability. The three kits that we developed in the frame of these projects are acronymed, are named as Smart Wall, Connex Wall, and Envelopes Comfort Wall. I will show them to you in the next slide. They have been developed by different technology providers, and they are demonstrated in 3 real demo sites and 3 replication sites. We use the user-centric approach to enhance the occupant satisfaction by implementing control-based methods and strategies. We also developed a digital platform based on BIM, able to handle a large amount of data through a decision support tool to support the designer in the selection of the optimal configuration of these hybrid kits, the PNU kits that integrate passive and active elements. We also implemented lean manufacturing principles in order to regulate the manufacturing in terms of minimizing material and energy use. We developed training tools, and of course, lastly, we implemented life cycle based performance standards, both for the environmental and the cost assessment. Here is a small picture of the 3 PNU kits that we developed in the frame of the Plural project. The first one is called Smart Wall. It's a hybrid system that includes in its prefabrication, as you can see from the photo, a PV element together with a control system and smart sensoring, as well as a fire suppression system and a fan coil, which collaborated together with the renewable energy source, the PV system, to create an intelligent multifunctional envelope component that can be very easily installed at any type of building. And on the right hand, you see the photo of the installation of the smart wall at the living lab at the premises of NTUA, of the National Technical University of Athens in Greece. The smart wall is also equipped with energy harvesting windows, multi-pane windows that include a heat exchanger and the special coatings that allow either to harvest heat during the winter or cool the interior space during the summer period. The second system is called Envelopes Comfort, and it is based on a pre-existing patent of the partnered envelopes in Spain. They were previously producing folding facades in the format that you see in the middle picture. And in the frame of the project, these folding facades were equipped with additional insulation layers and air handling units, small components that are integrated in the design of the folding facade together with PVs, and that are able to control the indoor air quality of the building that are installed. The third PNU kit, it's called Connex Wall, and as you can probably understand from the picture on the bottom left line. It's a hydronic system, namely a system very similar to an underfloor heating system, that it is integrated in the prefabrication of the facade, and it receives, it is operated with hot water, warm water, heated up via a heat pump, and a photovoltaic system. The challenge here is to make this system fit exactly the requirements of the pre-existing facade without having any losses in the heat transmission or the cool transmission through the hydronic system. All these three PNU kits were designed in such a way as to be installed at the existing facade of a building without having to remove anything from the facade. They are currently demonstrated in 3 buildings. The first building is in Athens, Greece, where we demonstrate the smart wall for the case of a Mediterranean climate with very hot summers, as it is in Greece. The Spanish demonstrator in Terrassa, close to Barcelona, we are demonstrating the folding facade system with the air handling unit of the envelopes, and the convex wall, the hydronic system developed by our partner in Switzerland, SPF, is demonstrated in a province of the Czech Republic, in Kasava, in an old building. You see here the old buildings before the renovation. Additionally, we have 3 replication buildings, one in Bern, where we virtually install and assess the performance of the convex wall, one in Berlin, which is already renovated, as you can see, using timber construction, and we compare the performance of the already renovated building with the performance of the smart wall. And we also virtually have installed the convex wall, the hydronic system, in a building block in Sweden, in Väsby, where we have a borealic climate. In this slide, I wanted to very briefly indicate to you what we achieved through the renovation of all these 6 buildings with the PNU kits that we developed in the Plural project. On the left side, you see the energy consumption of all the buildings at the pre-renovation stage. You can see here that clearly the space heating takes up most of the energy demand of the building, whereas the picture is totally different after the post-renovation state, where you can see that from 68% the energy demand for heating and cooling is significantly reduced. In the table in the middle of the slide, you can see the energy demand, the consumption, the power generation, and the non-renewable primary energy for all these buildings before and after the renovation, with a significant change and impact of the renovation with these hybrid prefabricated kits. So just very briefly, what we have achieved through this type of hybrid prefabricated renovation, we managed to reduce the U value of the wall from a target value which was set in the beginning of 0.23 watts per meter square Kelvin to well below this value. We managed to reduce the primary energy consumption per building to meet the local net near zero energy building standards for all 3 cases. We significantly reduced the equivalent CO2 emissions at the operational phase of the building, as you can see here, with targets well below the set targets at the beginning of the project. The materials that we use are highly recyclable, and we ended up with a good number of system combinations, demonstrating the adaptability, tunability, and flexibility of this type of renovation. So where are our systems applicable? The convex wall, which is the hydronic system, which I showed you before, it's especially appropriate for cold climates, for buildings that are constructed before 1904. It can be applied only on the external wall surface, and it can reduce. This is an average value for different countries with cold climates. The U value of the existing building from 0.7 to 1 point, which normally ranges from 0.87 to 1.36, to a much lower value, as you can see here. The smart wall is appropriate for all climates, apart from the extreme cold ones. It is appropriate for buildings constructed before 2006, up to 4 stories, and it is able also, as you can see from the figure, to reduce significantly the U value of the wall. The folding facade wall of develops comfort. It is also appropriate for all climates, apart from the extreme cold climatic conditions, for buildings before 2010, and it can go up to 7 stories. Again, with a significant reduction of the U value. I would like here also to add that the smart wall can be implemented either on the external or the internal facade of the building to be renovated. What did we learn out of this project? First of all, we were able to demonstrate very successfully that this type of hybrid kits that take into account the user requirements through their control systems and combine active with passive solutions can be efficiently manufactured to integrate renewable energy sources, various types of heat pumps, ventilation, air handling units, hydronic systems, and they can achieve efficient operation. They can also be equipped with storage equipment like thermal or electrical. They can be designed and constructed using low carbon footprint materials, and all those can be part of the initial design of these adaptable kits. They are flexible solutions, including EV charging, and they can be effectively integrated in solutions for decarbonized, adaptive, and regenerative built environment. What are the challenges in terms of market uptake and implementation? Of course, for the manufacturer, they need to adapt the design to the building characteristics, which necessarily creates a very large database of alternative designs that have each time to be designed and manufactured to meet the specific needs of each building. So this leads us to believe that there is a need for new business models that will change the traditional way of manufacturing this type of hybrid systems and create new collaborative opportunities for the prefabricated industry, combining expertise and collaboration from the digital environment, from the digital technology environment, the renewable energy sources, the control systems, and also the carbon neutral materials. There is a lack of a regulatory framework for active building facade components. There is no regulatory framework for the certification and assessment of this type of hybrid kits that combine active and passive systems. And last but not least, the acceptance, it is currently restricted due to the lack of large-scale demonstrations, the lack of long-term performance evaluation, harmonized standards, and economy of scale to reduce the costs. So with this, I conclude the presentation of the Plural project, and I would like to go forward to introduce you to the notion of the zero emission building, which is defined as a building which has a very high energy performance. That immediately leads us to understand that the envelope of the building should be very well insulated, both from the opaque and the transparent components, and that requires a very low amount of energy, which is fully covered from renewable energy sources without on-site carbon emissions from fossil fuels. So this puts a new challenge that we need to have renewable energy sources that have very small or minimal environmental footprint, which can be counterbalanced at the operational phase of the building by the advantages of carbon neutral materials or biogenic materials or waste materials that are introduced in the design and construction of prefabricated systems. So this is exactly what we are trying to do in the Greenest project. We are trying to contribute to the EU future of zero emission buildings by demonstrating key ways to reduce the building emissions. And we do this by promoting 100% carbon-free construction that not only meets the near zero energy building status, but also ensures reduction of the greenhouse gas emissions at the operational stage of the building by 60%. We aim to increase the productivity by 30% based on local value chains, using digitized, time-efficient, prefabricated design, manufacturing, construction methods for timber, used timber, and prefabricated earthen components, developing, again, flexible and adaptable components, and promoting the circular. So let me go on. What are we doing in the Greenest project? We are developing what we call 16 standardized packages. These are solutions that go from the level of material. We are developing systems that are based, for instance, on coffee bean waste, on waste wood material, on dowel laminated timber. We develop a number of solutions that are based on digital tools that can control effectively the production of embodied and end-of-life carbon. We develop a number of design solutions, design by inventory, which is a scheme that aims to limit the material used during the design phase of the building, and the Delta Smart design scheme, which aims to be implemented as a modular design concept for buildings. These are combined to deliver envelope systems, which and we are targeting 5 different envelope systems. 3 of them are opaque envelope kits. 2 of them are windows, transparent. And last but not least, we have 3 active systems, technical systems, building integrated PVs, heat pumps that are operated with eco-friendly refrigerants, and a control system which is based on indoor air quality sensors, and it exploits a centralized control system. All these 16 standardized packages are combined and implemented in 4 different demonstration buildings, which are a lighthouse to our understanding. The first one is a very innovative building, which is going to be constructed in 2025 by the Technical University of Berlin in Berlin at their headquarters, aiming to demonstrate all the principles of bio-based construction. And in this building, we are going to demonstrate the envelope systems that are going to use the waste from coffee beans together with recycled wood and heat pumps and PVs that will have a very low environmental footprint. The second building is a residential building, again in Berlin, and we are going to construct the top floor of a house of student housing, totally out of recycled wood, with heat pumps and again photovoltaics to reduce the operational footprint. The third building that we are going to construct, it is on an island in Greece where they have limited access to resources, and we are going to use local materials, stone, recycled wood, and ship wool to construct a building that will be used as a youth recreational center. And I think I jumped one. Here it is. It is a very nice also demonstration case in Porto Viro in Italy at the delta of the Pau River, which is a protected area. And we are going to construct there a lodge for fishermen with green walls where they can, the green walls will be equipped with vegetation that can be used by the fishermen during their recreation time. So all this we expect to give us a number of innovative outcomes in terms of materials, in terms of design tools, technical systems, building envelope systems, and to demonstrate it in the 4 different buildings that I just showed you. And the long-term impacts that we expect to achieve at the end of this project, which just started in January and it will last for 4 years, it is to promote the use of nature bio-earth-based materials to reduce emissions by more than 20% by 2050, to reuse building materials and components to lead to a potential emission reduction of more than 10% by 2050, through the innovative design procedure, again, to reduce material consumption by more than 10%, to implement digital tools in material design to avoid waste, reducing again emissions by 18%, through the use of local rests with low environmental footprint, refrigerants in the case of heat pumps, and coatings in the case of building integration PVs to reduce the emissions for the whole life cycle by more than 25%, and enhance user comfort with the potential emission reduction by more than 11% by 2050. So these are very optimistic challenges that we will have to prove during the course of this project. And with this, I would like to thank you for your patience and attention. And of course, I would like to send my special thanks to all the Plural and Greenest partners for their collaborative spirit and their constructive works. So thank you very much for your attention.
Thank you, Maria. Always a pleasure to hear about the projects that you coordinate, very prolific ones. Great to know many types of technologies are being demonstrated in different sorts, different ways. We are very, very late already in the schedule, but I would like to pick up two questions here from the audience to Maria. Probably I would start with Carlos, which asks, which are the market-related bottlenecks for the wider acceptance of active facades? And then I would pick another one. So Maria, can you give us
Yes,
some?
I already mentioned this briefly in my presentation. First of all, for me, the first bottleneck is the lack of appropriate business models. The hybrid prefabrication industry should be based on local value chains, exploiting local materials to make them reusable, more environmentally promote the circularity based on the environmental principles. On the other hand, the energy systems are, as we all know, manufactured and produced by consortia, multinational consortia, which have a totally different characteristics for the from the SME and local characteristics of the manufacturers of the prefabricated components. And at the moment, there is no direct collaborative framework between the developers of the passive envelopes and those that produce the energy systems, the control systems, and everything else. And of course, there are no economies of scale because there are not many examples of such renovation projects. But I believe that they are very promising, as it has been demonstrated through the Plodal project, as well as other EU-funded projects that developed similar hybrid facade systems. So the challenges are, first of all, economies of scale, having more projects to be able to reduce the fabrication, the manufacturing and the production costs, and also new schemes for collaboration between the stakeholders to be able to integrate them and reduce again the costs.
Yeah, you're right. You're right, Maria. Just to finalize, Maria, last question, because there's another one, but I would just pose you one to wrap up. Is it possible? This is from João Duarte. Is it possible to reach zero emission building status after deep renovation?
That's really a very tricky question that actually relates very closely to the presentation of Callum. Very difficult, especially if we are talking about old buildings. Buildings constructed, post-war buildings, for instance, where we don't know the quality of the materials used, and the energy systems that are installed in these buildings are not compliant with the latest regulations in terms of their environmental performance. So from my understanding, the roadmap for zero energy building should first focus on the new buildings, as correctly the recast of the EPPD foresees, and develop new technologies, both active renewable energy technologies, as well as passive elements that would be able to reduce the environmental footprint, not only at the operational stage phase of the building, but also the upfront, taking into account reconstruction, reuse, local reuse of materials, for instance, dismantling of existing windows and upgrading to reuse them in the same building, or putting a second layer of windows. So there are a lot of practical techniques that can be done in the renovation of any type of building to go towards a zero emission building. But overall, I believe that it is extremely difficult to say today that we can reach zero emission status for existing buildings, especially the post-war buildings, and which were constructed without the current regulatory framework.
Yeah. Many thanks. Completely agree with you, Maria. So we are
Thank you
just
very
we are just closing to 6 o'clock Central European time. So we should probably close it for now. Unfortunately, we already suppressed a little bit our schedule, and we need probably to call it for day. We will skip the question and answer session because we already made it these questions at the end of each presentation. And again, if any question arise, late question arise, I believe that speakers will be available after the workshop to answer by email any remaining question. I hope that this workshop, at least for me, it was very fruitful and provided our audience with a glimpse of the latest technology developments that we are working with towards a more sustainable environment, and that probably we might have made a small contribution, if it's a very slight one, to inspire everyone to embrace innovation and drive this so much need transformative change in the building sector. I would like to express my gratitude to all the speakers' availability and wonderful participation. It was great to have you. Also to the online participants that stay with us for this 3-hour workshop. Let's continue to work together towards this shared vision of sustainable and energy efficient building design for a more viable tomorrow, because we really need it. Thank you all for joining us, and until next time, kind regards to everybody. Bye bye. See you next time.